Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Welcome to Chapter 8.7, Finding Volumes with Square and Rectangular Cross-Sections. I will be your teacher today. My name is Dylan. This is Student to Student. So we're going to start with finding the volume of a graph with square cross-sections. We're going to start by looking at the formula, which is v equals the integral from a to b of s squared ds. And one thing you'll have to remember is for when the cross-sections are perpendicular to the x-axis, you'll be in a dx, but if they're perpendicular to the y-axis, you will be in dy. So to find s, you do f of x minus g of x if we're in dx, but if we're in dy, then you do f of y minus g of x, or g of y. And this is because you take the top function minus the bottom function when you're looking at x, and you do the right function minus the left function when you're looking at y. So to learn this, we're going to look at an example. We're going to get this graph, f of x equals x plus 2, and g of x equals x squared. The first step is going to be to find s. So we use the formula to find s, and you do top minus bottom. So it's x plus 2 minus x squared. Next, you'll plug that s into the formula. So we have the integral from 0 to 2 of negative x squared plus 2 squared dx. And it's dx because we are looking at x. And one thing to remember is these are definite integrals. And here we're going from 0 to 2. So those are the limits that we're using. So the 0 to 2. Next, we're going to be evaluating using a calculator or by hand. And that's something that you will have learned in a different section, how to do it by hand. So we're just going to do it by calculator here. And we get 6.4. So the volume from 0 to 2 with square cross sections that are perpendicular to the x-axis is 6.4. Alright, so next we're going to be looking at finding the volume of a graph with rectangular cross sections. So the formula is just a little bit different here. Volume equals the height of the integral of s ds. And the reason it's different is because with a rectangular cross section, the two sides can be different shapes. And because of this, we have to multiply by the height. And we can't just do s squared because they're not the same side length because it's not a square. Finding s is exactly the same. F of x minus g of x, top minus bottom. Or if we're looking at dy, it would be f of y minus g of y, or right minus left. Now we're going to take that same exact example again, x plus 2 and x squared. And this time, because it's rectangular cross sections, we know that h equals 2. That will be given. The height will be given as a function of x or just a normal straight number. So in this case, the height is 2. So let's take a look at the steps. First, we have to find s. It's the exact same thing. X plus 2 minus x squared. That would be top minus bottom. Then we plug s into the formula. So here we have v equals 2, because that is the height. The integral from 0 to 2. Once again, we're going from that 0 to 2. Those are the limits. Negative x squared plus x plus 2. We don't have to square it this time because we do have the height that we have to take into consideration. That's why that is there. Once again, definite integral from 0 to 2, and the height will be given in the question. So next, we will evaluate using calculator or by hand. Once again, we're going to use a calculator, and we get the volume to equal 6.667. And like I said before, here the volume from 0 to 2 of this graph, inside this with rectangular cross sections that have a height of 2 that are perpendicular to the x-axis, the volume is 6.667. All right, so now we're going to take a look at an FRQ. FRQ comes from flipped math. So the base of a solid is bounded by y equals x to the third, y equals 0, and x equals 2. That is this graph over here. We're going to find the volume if the cross sections taken perpendicular to the x-axis. That right there, taken perpendicular to the x-axis, shows that we are in the dx, so we're doing top minus bottom when it comes to finding s. These cross sections form a rectangle whose height is 2 times the width. So now we have a function of x for the height, and we'll see what we're going to do with that in a minute. So first, we're going to take the function for rectangular cross sections. It's a little different from the one that we saw on the other side because here we have the function of x, or in this case a function of s at the moment, but it's pretty much the same. We have the height there. So it's the integral from a to b of s times the height, which is a function of x, ds. Next we find s. We do the top function minus the bottom function, and in this case it's a 0, so x to the third minus 0 just equals x to the third. Then we plug it in here. We have the integral from 0 to 2, x to the third of 2x to the third dx. And then you just evaluate using your calculator or by hand, depending on the question, and you'll get the answer. All right, so the next question for this FRQ is find the volume if the cross section's taken perpendicular to the y-axis. So this part is very important. Perpendicular to the y-axis means that we're looking at the y-axis. We're in dy, which means that we need to find s, we need to do right function minus the left function. And the cross sections form a rectangle whose height is 6. So now, once again, our formula is just the height times the integral of s ds, and the height's 6. It says that directly in the question, so we know that. Obviously, that's the function. Now, to find s this time, we're going to be looking at right minus left. Right function is 2, and the left function is the third root of y. Now, we're going to take that s, plug it into our function, we get 6, integral from 0 to 8. Now here, we want the 0 to 8 because we're on the y-axis, and we want from the point where they meet here to the point where they meet up here. So that's the full shape. So it's from 0 to 8. And then we take our s and plug it in. So we have 6 times the integral of 0 to 8 of 2 minus the third root of y dy. And then you will evaluate using your by hand or by calculator, depending on the question. Thank you for listening to my presentation on Chapter 8.7, Finding the Volumes of Square and Rectangular Cross Sections. This has been Student to Student. I'm Dylan, and good luck on your AP test.